We're moving on to section 1.5, and we want to be able to simplify expressions involving exponents and use scientific notation. In an expression of the form a to the n, little vocabulary here, a represents the base and n is the exponent. The exponent indicates how many times the base is used as a factor. So if we write this out, a to the n, a is the base, n is the exponent. That means we have to write a down n times and multiply them together. This is called the expanded form. So let's go down to the table here, and I put a little star next to this. When the base includes more than one symbol, it's written in parentheses. That's really important because you need to know what the exponent applies to. So in exponential form, I have 3 different examples, and they look very, very similar. But when you write them in expanded form, you can see that they're different. Here, the 4 exponent only applies to the x because x is the base. And we write just the x out 4 times as a product. Here, the parentheses are around 3x, and that's being raised to the 4th power. So this 3x is the base, which means the negative sign gets written here, and then we write 3x out 4 times and multiply that together. The last one, the negative sign is now inside the parentheses, and everything is being raised to the 4th power, so this becomes the base now. And that's what gets multiplied together 4 times. So be very careful. These look very similar, but as you can see here, they're different. So pay close attention to the parentheses. All right, the next one we need to go over is 0 and negative exponents. All non-zero real numbers a and b, and n is an integer. So one reason why we went over classifying numbers is because now we're going to use them to describe different things. The 0 exponent property, I have, can't see the little red stars over here, but that has to do with a non-zero quantity that's raised to the 0 property, and it's always going to be 1. It does not matter what it is. We have 100 to the 0 equals 1. So any real number raised to the 0 power equals 1. I can have a big number, raise it to the 0 power equals 1. It is not 0. A lot of times I'll have students tell me that a number to the 0 power is 0. That is not true. Negative exponent property. A non-zero base raised to a negative exponent is equal to the reciprocal of the base raised to the opposite positive exponent. Okay, so what happens when we have a negative exponent, I call it a flip and switch. You flip or take the reciprocal of the number or the base, and you switch or you change the exponent sign from a negative to a positive. All right, so here's an example. If we have 7 to the negative 2 power, 7 you can write as over 1, so we're going to take the reciprocal of that, which changes the exponent from a negative to a positive, and now we just have to do 1 over 7 squared, which is 1 over 49. Another example, 3 halves to the negative 4. We take the reciprocal of 3 halves, which becomes 2/3, and now the exponent changes from a negative to a positive, and that's going to be 16 because we square the 4 and we raise 2 to the 4th power and raise 3 to the 4th power, so it's 16 over 81. Don't forget to do the numerator and the denominator when the fraction is inside parentheses. Parentheses are very important. Pay close attention to them. All right, so here it's written out algebraically. Do not confuse a negative exponent with a negative expression, however. Here we have a negative exponent. Here, this is an expression, so you cannot move the negative on an exponent out in front of the base. Those are not the same thing. On the next page, we have some properties of exponents that we need to go over, and I've highlighted the operations. When you have 2 bases that are the same and they're raised to a power, we just add the exponents. And I'm going to show you why that works. If we write it out in expanded form, if we have a cubed times a squared, this means a is multiplied by itself 3 times, This means it's multiplied by itself 2 times, and when we write them all out, we get a to the 5th power. So if you forget on a test or a quiz, just write them out in expanded form. I'm going to do the same thing with the when you subtract your exponents. Here we have a cubed over a squared. I'm going to expand both of those, and as you can see, these will equal 1. So 3 minus 2 is a to the 1st power. I did the same thing with a squared. I raised it to the 2nd power, and we multiply those exponents, and this is why. This means, right here inside parentheses, means a times a. This means to write this 2 times. So a times a, I write it again, a times a. It's going to give me a to the 4th powers. Product of powers. I need you to change something for me. I need you to cross this off, and we're just going to change that to 5 squared times 5 cubed. The bases have to be the same. When the bases are the same and you're multiplying, you're going to add the exponents for this reason up here. So we have 5 to the 5th, or 5 to the 5th is going to equal not 25. Let's just erase or scribble that out. 5 times 5 is 25. 5 to the 5th is going to equal 3,125. All right, then an example of the quotient of powers property. First thing we're going to do is, order of operations says we need to do the parentheses. So we're going to subtract our exponents here, which will give us a negative 3, and then we still have this exponent out here. So now we have a power being raised to a power here and here. It doesn't look like it, but there's a 1 here. If you don't have an exponent there, you should know that that exponent is 1. So we're going to multiply this to get 2, multiply this to get negative 6. And when you are simplified, you cannot have a negative exponent. So we're going to take the reciprocal of this, so b would be over 1, or basically what we're going to do is, if we put this over 1, then we can take the reciprocal, so it would be 1 over b to the 6. So we just put that in the denominator, and now that is simplified. Power of a power property. Here, be really careful with this. You want to make sure that the 3 is an exponent for the 5, and it's also applied x to the 6. So 5 cubed, and then, because this is the base, so everything has to be cubed inside, and then x to the 6 gets raised to the 3rd power. So 5 cubed is not 15, it's 125 because it's 5 times 5 times 5. And x to the 6 raised to the 3rd power is x to the 18th, 6 times 3. So here are just a power of a product property, so which means you're multiplying inside, then raising it to the power. So 2 would be the power for 3 and for 4. And here, this is the power of a quotient property, which means when there's an exponent on the outside of a fraction, you're going to raise the numerator and the denominator to whatever that power is. All right, last thing we need to do is to talk about scientific notation. That's a method of writing numbers using powers of 10. And when you use scientific notation, a number takes the form m times 10 to a power. Now, m is going to be less than 10, but it is going to be greater than or equal to 1. So m is an integer. And m is an integer, I should say, because it's in between here, excluding 10, including 1. So scientific notation, here's a couple of examples. If you raise it to the power of 10, the number has to get bigger. So we move the decimal. Every time you multiply by a power of 10, the decimal moves 1 place. So here it moves 7 places to the right. If it's a negative exponent, it moves in the opposite direction because the number gets smaller. Now be careful when you are dividing or multiplying numbers in scientific notation. What you do is you divide the numbers, and then the bases are the same, so you subtract the exponents and then you write it in scientific notation. So I wrote dividing m's because this is the m part. It's in between greater than or equal to 1 but less than 10. Those are my m's. So I'm dividing these values to get 0.25, and then I'm going to subtract my exponents. 6 minus 9 gives me a negative 3. When I put that in scientific, I need to put it in scientific notation. This is what I get, but that's not scientific notation because this number has to be, take that into consideration. So what I need to do is I need to move this decimal place, because this is less than 10, I need to move the decimal to the right, which gives me 2.5. Now, if I'm multiplying this by a power of 10, or increasing it by a power of 10, this has to decrease by a power of 10, or the value of my number is going to change. So as I increase this by a power of 10, or whatever power of 10, I have to adjust this power of 10. So this now, instead of being to the negative third power, it's going to be to the negative fourth power. All right, we're going to do a couple of examples on the next page, and then you're going to finish it up for your turn. This says just expand each expression, which means you're going to write out what the exponent is indicating. So this just should have 3 c's multiplied together. The 8 is on the outside. Pay attention to location of negative signs I wrote in here. So here, we're going to take, I think this is similar to the one that we did on the other page. Or actually, I think it's the same question. So anyway, you take if you have a negative exponent, take the reciprocal of the fraction, and then the exponent changes from a negative to a positive, and then you just raise the numerators to the second power and raise the denominator to the second power. And down here, they've started this question for you. The exponent is applied to everything in the parentheses. So the negative 5 gets squared, the a gets squared, the b cubed gets squared. And when you raise a power to a power, things get large quickly. So that's when you multiply. So our final answer, when we square that, we get 25 because the negative is inside the parentheses, so that gets squared as well. This is a squared, and we multiply these exponents to get b to the 6th. Last one here. We're going to divide the numbers, which will give us 2. We're going to subtract the individual exponents on the bases that are the same, so s and s here. So it's going to be 3 minus 1. You don't see an exponent there, but it's 1. So it's going to be s squared. We subtract the exponents here, and we get t to the negative 1. But again, you cannot have negative numbers in your exponent. So we're going to take the reciprocal of this. This is like t over 1, so we'll flip it, or what we do is we can just write it in the denominator. So that's 2s squared over t. Okay, and you need to finish the rest.